Welcome back to another podcast from the Association for Materials Protection and Performance. My name is Ben Dubose, and I'm a staff writer with Materials Performance Magazine, also known as MP. Today, in the latest episode of our ongoing MP interview series, we're continuing our latest series spotlighting many of the newer technologies designed to assist with the war against corrosion. In late April, as many of you are likely aware, we announced the 2021 winners of the MP Corrosion Innovation of the Year Awards program. These winners, which you can read about at materialsperformance.com, were graded and judged by a panel of industry experts across numerous fields and sectors within corrosion control. Over the coming weeks and months, we're inviting each of these winning groups onto the podcast to talk a bit more about their innovation and how they think it can potentially change the corrosion industry in the years ahead. So on that front, with us today, we have Solveig Parent, Tristan de Servines, both of Heuris-Tech, and Dr. Ramiro Castaneda Lopez of Texas A&M University. As you may recall, these groups were recently honored in the Corrosion Innovation Awards for their differential reflectometry mapping technology, better known as DRM, and that's what we're going to be discussing today. Folks, welcome to the podcast. I think a good place to start, if each of you would just introduce yourself and tell us a little bit about your career in the industry and your role where you are right now. Tristan, we can start with you.
Yeah, thank you very much, Ben. So I graduated from Arts et Métiers Paris Tech, which is French engineering school, before being drawn to research in material science and, of course, especially corrosion. I joined Texas A&M University and Dr. Romero Castaneda's research group as a grad student. And then we carried on by, after the research that was done in the lab, by creating Heuris-Tech, which is a startup company dedicated to serve the industry with this new technology, DRM.
Solveig, you can introduce yourself.
Yes, my name is Solveig Parent. I graduated from a top-tier French business school, after which I started working in sales and marketing in a big corporation. I then seized the opportunity to join the adventure and co-found Heuris-Tech. I bring a complementary insight in the managing team where I am in charge of business development.
And Dr. Castaneda Lopez?
Sure, thank you, Ben. I want to be short. So I graduated in 2000 from Penn State University. My PhD was in material science and engineering. From there, I spent around 12 years in industry, from water business to oil and gas, everything or every time in the corrosion areas as an expert or as an engineer. After that, then I joined National Lab, which was Battelle Memorial Institute, also as a principal research scientist. And from there, I joined academia. So I think finally I end up having my my area and my expertise in a place that I enjoyed the most. So I joined academia in 2010 in Akron University. And from there, I moved to Texas A&M. Currently, I am the director of the National Corrosion and Materials Reliability Lab at Texas A&M University, and also I'm associate professor in material science and engineering. Thank you.
So let's talk a little bit more about DRM. And for the sake of our audience, not everyone is going to answer every question. I'm going to let each of these three jump in whenever they think a certain question is sort of in their wheelhouse, if you will. So I think an appropriate place to start as it pertains to DRM, just tell us about it. What is it? How does it work? Basically give us an executive summary, if you will, of this technology that you all developed and what it does within the overall field of corrosion control.
That sounds good. So the good thing is it's pretty simple. So the way it works is the following. It's electropulses that are sent into the pipeline systems, which act as a very nice waveguide for this type of signal. And the locations of the defect are worked out with the time delay of the signal reflection. So it's very much the same principle as the radar. So this way, our innovation, it's really about using reflectometry of electromagnetic waves to detect and locate any coating holidays, delaminations, and other defects. So this represents a true paradigm shift regarding pipe corrosion inspection.
So what are the end applications here? Tell us a little bit about the end users of this and how this is potentially put into practice in the field.
The most important end application of the technology DRM is as a complement to legacy pipeline coating assessment techniques. For electrical utilities, oil and gas, heating networks, this technology allows them to have a precise knowledge of their network state. Thanks to UV-stack technology, we want to change corrosion management from being reactive to being more preventive and even predictive.
So what was the driving force to develop this technology? What was it? Well, I guess a good place to start is if you could explain, number one, how long you've been working on this, but also just what were the reasons in terms of the options available or not available on the market that sort of became the driving force for the development of this?
So I'd say in the industry in general, this has been, a long problem, a long bane of the industry. And so personally, I started to work on this, so joining Dr. Castaneda's lab. So it was in fall 2015. And the project, it all started as a research project brought to us by a sponsor. And it's really this original sponsor need that has been the original driving force to develop this technology. Because this company has a large sprawling network of feeder pipes, all in a very dense urban environment, which is a very challenging environment to work in because of the difficulty to access those pipes, including from the surface. So that means that many legacy methods don't work in this environment. And so this is what prompted the sponsor to start something new with Dr. Castaneda and to start the project that eventually led to the development of this technology.
So what were some of the historical limitations? And, we can just take a step back here. When it comes to the detection and measurement of pipeline corrosion, what are some of those challenges historically, and how does DRM specifically overcome those?
Sure. The thing is that historically, I remember since 1996 that I joined my PhD program. So my thesis was related to location of defects in pipelines. So since then, the issue of the pipelines that you use for transportation of assets in terms of oil, gas, or any other asset is because of the fact that once you set up the pipeline, you cannot see it. So it's an indirect asset or a remote asset that you cannot have access. Accessibility is important to see that once you set up the pipeline, you have no idea what is going on with that pipeline. Then since 1996, again, I remember that I joined and I started the PhD program by looking at ways to detect or locate that any event or any issues in the pipeline. So the problem since then is been the soil also, the soil that is the media that attacks or corrodes the asset, the metallic asset, regardless of you have a coating or protection or not. So since then, many technologies have been developed and they are good. However, there are some issues still that we couldn't detect, basically because of the soil conditions. The soil conditions are very complex, and one of the ways that DRM was able to overcome all the issues that historically have been existed is the fact that you, as Tristan mentioned before, you put a signal on the pipe, and the signal goes all the way to the pipe, but the pipe is interacting with the soil. So at the same time that you are considering the soil, you are avoiding the soil to measure any issues in the pipeline. So the development has been through years, and again, DRM is one of the technologies that we believe that is one of the answers to overcome any issues, specific issues in the pipeline community. Again, is complementing what is existed. There are many survey techniques and inspection tools that allows you to see what is going on with the pipeline. But this is, as Tristan mentioned, this is a paradigm shift, because this is a new way to inspect, and also the overcome is very successful so far.
So what type of field testing has there been specifically? Can you tell us a little bit about the results to date that you've seen from using DRM?
Yes, and of course we have to be careful to respect some confidentialities.
Sure.
Concerns, but basically early field testing could be started as soon as 2016, and so we had with correlation between in specific sections of the network, correlation between indication given by DRM and indication that could be obtained otherwise, and then with the success, with this initial success, we could capitalize on this and conduct large field, large-scale testing and those were good validations as well. And so from then on, the rest is history of successful field validation, of increasing sizes and scopes, and repeated incremental improvements from this field experience to optimize the entire process, from the data collection to the data processing, analysis and interpretation, and then the decision science, the decision making from those indications for the best management of those assets.
So, Dr. Castaneda Lopez, we already touched earlier about how Heuristic and A&M are working together and where the lines are. If you could, just for anyone that's sort of confused on the outside and wondering, well, not so much how this came to be, because you explained that earlier, but where is the relationship now? Specifically, what's Heuristic, what's Texas A&M, and what is this overall collaboration like?
I see. So basically, Texas A&M is helping. It's of course an educational institution, an academic institution. So primarily, we care about the students' preparation and knowledge. But at the same time, as Tristan mentioned, we have opportunities to do research. So it's a very good way to see that the research that we have, it can be useful. So what we do is in the Texas A&M, we help if there is any good research that had a good overcome, a good application, and a useful application for users. So what A&M is helping is to or encourage to open a business or a startup company. So that's the beginning from A&M standpoint. But now, since we believe that this very mature, the company is not only a startup in the sense, but also is a mature company that can have their own legs. So we just there to support like intellectual property. So things maybe technical, but we believe that now the relationship is mature enough that Heuristic is taking their own steps, their own future. And A&M is there still to help with the IP, because it was the location where the technology was conceived. Of course, Tristan was the main and the most important author. So again, the text A&M is just to support in some areas, but I think heuristic is it's mature enough to continue the journey to really solve interesting and unique problems.
So now that this is commercially available, what feedback have you all gotten in the first couple of years that this has been on the market?
Yes, of course. Let's talk about the client feedback. The first reaction of our clients is happiness about the visibility they gain on their network. It's a bit like they get eyes on a threat they have been so far blind to. What's more, they are impressed with the accurate coating defect location DRM can provide. It allows them to cut to a minimum the excavation costs. In fact, they are so satisfied with our technology that they want us to train their crew to perform DRM data collection, while Heuristic will still be in charge of the analysis. By doing so, we will be able to expand the use of our maintenance tool to the totality of their network. Generally speaking, it is extremely important for us at Heuristic to be very attentive to client feedback, whether from field crews regarding operational aspects or from corrosion department regarding data display and interpretation. It is our priority to really tailor our service to best fit their needs.
So are there any changes, updates, modifications based on the feedback that you've gotten, or any tweaks that you want to make to this going forward? Are there any modifications coming to this technology over the next few, I suppose, months, years, whatever it may be?
So some of the new directions we decided to go. So that includes working on the modularity to make it as simple and practical to use in the field for the data collection part. So I mean, that's not really a change in the technology itself, but more in the way it is used practically in the field, and because we have one foot in the lab in the conference room, but at the other foot is firmly in the field. And so it's not just about having nice science. You also need to have nice tools that are very easy and practical to use to make a technology a very successful tool for the industry. So while we don't expect much to change on the theoretical part of the technology, another thing that we want to also develop as our library of successfully excavated defects grow. So this library is going to be very useful to us at the same time make our modeling library as rich as possible, but to open the door in the future for possible machine learning for machine learning development. We need a very extensive library, and so we are building it as we speak to be ready to open that new direction.
Mm-hmm. I think this is really good insight for any of our listeners that want to find out more information. Well, certainly on our end, you can go to the MP Innovation Awards website, which has the full application from Heuristic for the what became their successful award, and has lots of background details. But for any listeners wanting to get even more information than that, where can they get it? This can certainly be your website, any contact info for you all. Just as we wind down, what are the ways that listeners can access more info about DRM?
Yes, indeed. Please do not hesitate to check our website at uristech.us or contact us at the mailing address contact@uris.tech. Thank you very much.
Thanks for joining. Folks,
Thank
this
you.
is where we will wrap up on today's show. If you want more info, of course, they just mentioned where you can find it with Tech and Texas A&M, but you can also check out the AMP website, ampp.org. You can also visit materialsperformance.com, and of course, the awards website, which has information specific to DRM and other technologies that were judged to be finalists, or in the case of 10 lucky winners, through the 2021 program. With that, we'll sign off. Once again, I'm Ben Dubose. Thanks as always for listening, and please come back soon for another podcast episode from the MP Interview Series.